Okay, I think we should probably get started. It's possible that some people are gonna, come on in a little bit later. Sometimes that happens when we do this, obviously. And we are definitely recording this so that everyone has access. Correct, Jim?
Yeah, that's right.
Okay. So I want to thank you all for joining us. We know you have busy schedules. So our goal is to provide you with great information to help you, all of you in your roles. We are Nabto. Our specialty is IoT. This is the future of IoT. And I'm Tariq Hassan, the business development lead here in the United States. And we have with us here also Jim, who's head of our department globally, in the top left, and then also Karsten, who was our CEO and founder of Nabto in Denmark. Thank you, Jim and Karsten. We look forward to receiving this information. And everybody that's listening in, if you have any questions, we're going to have a question and answer session at the end. So please stay tuned so we can make sure all your questions are answered. In the meantime, if you want to type them in, feel free to type them in into the chat box. Thank you very much. Thanks, Karsten.
Thank you.
Oh.
Yes, everybody, welcome to this webinar about WebRTC and how you can apply this to IoT. This is not a super technical seminar. It's more, the goal is more to give an 10,000 feet overview of WebRTC and how this can be applied to IoT. We will show some schematics and some charts, but it's more going to be a high view overview of WebRTC and how that actually works. Can you see the presentation? Just want to make sure that it is presenting.
Yes.
Okay, super. Great. So the outline of the webinar is basically in two parts. It'll be around 30 minutes in all with a Q&A. And the two parts is what is WebRTC, which will start by defining real-time communication, and then how real-time communication and you can say the web, how these are joined to actually make up WebRTC, and then a short and not that technical overview of WebRTC, how the architecture actually plays out. Then the second part is how WebRTC actually plays a role in IoT. Of course, in video and audio application, as we'll see, but also how it actually plays out in application of General IoT. And then it will end off with a prediction about real-time communication IoT and cloud IoT. So what is WebRTC? This new technologies that you probably starting to hear. Of course, this is WebRTC is based out of real-time communication, and I tried to find a definition on I think it was Wikipedia where this definition comes from. So real-time communication is a methodology that lets devices communicate in real time without transmission delays. And normally it is based out of peer-to-peer or what is called NAT traversal architecture. Or more simple definition that I put in here, it's basically direct communication A to B between two peers on the internet. And examples of this that sometimes has nothing to do with WebRTC, even though a lot of these architectures today actually transitions to WebRTC, or at least make it possible to connect with WebRTC, is, for example, Teams, Google Meet, Skype, Zoom, FaceTime. These are all based on the general real-time communication technology, creating these direct connections. Sometimes via web and WebRTC, and sometimes inside the application of, for example, Zoom, if you have started Zoom today. That will be, you can say, a real-time communication channel without the web part. WebRTC, what is the challenge? Actually creating a direct A to B connection on the internet today is not that simple. When I started out on the internet, and that's a fairly long time ago, if you had an IP address, you could send this IP address to another peer on the internet or another client on the internet, and they could actually use this IP address to connect to the computer you set on the internet. That's not how the internet works today. Everything is behind firewalls today. And the job of a firewall is to protect the client or the entities that are behind the firewalls from, you can say, unauthorized connection coming from the internet. So creating these direct connections between two clients behind a firewall is actually quite hard. But techniques exist to do this. Mostly they are referred to as NAT traversal, sometimes also peer-to-peer connections. And this capability, which is basically creating these real-time communication channels, is actually, WebRTC is just, you can say it's, WebRTC is basically that you have taken these techniques and you have integrated them into the browser of today. So, and you have done that in a standardized way. And the goal of WebRTC is to use this, so these direct connections. The goal of designing WebRTC when it started out was to use this for browser-to-browser communication only, actually. But as we'll see later on in the webinar, this can actually also be used as an IoT connection facility. So instead of a browser to browser, it could be a browser to an IoT device. But again, creating this direct connection, that is what WebRTC actually standardized. And why do we want this real-time communication? I've put in here the three most prominent advantages of real-time communication. So the first, of course, being latency. And if you have tried to be on a slow phone line, a phone line with very high latency, let's say up in a second or 1,000 milliseconds, you definitely have found out that it's very hard to actually carry a conversation if you have too much latency. And sometimes you can do it even with high latency, but it will be some, you'll try to make some kind of walkie-talkie protocol where you say, well, over, because otherwise you tend to talk in each other's speech. Yeah, and again, it's, you can test it out. Making conversation with just a little latency actually gets very, very hard. And again, if you want to remote control something, then high latency can also be an issue. We have a client, a customer who uses our technology to make it possible to drive a small, you can call it an RC car around with a camera. And again, if you just read something like 200 milliseconds, it's actually very, very hard not to crash the car, because it takes 200.2 seconds to actually, from you do a command to the car actually responds to this command. And that's enough to actually make it very, very hard to drive the car. But also just to control a pan PTC, which is pan, tilt, or zoom control of a camera. Because again, if you try to let's say you're trying to tilt or you're trying to pan the camera, it actually normally you overshoot the target, because once you lift your finger off the panning button, the camera will continue for, let's say, 200 milliseconds let's say 500 milliseconds, and actually makes it very hard to actually do these, to remote control just a simple camera. But again, also if it's a smart lock or a smart alarm, it doesn't even have to be video now. The application I've talked about here is video based. But let's say you're standing out in the rain and you want to open your smart lock or you disable your smart alarm. If you have 1 to 2 seconds of latency, that's going to be a problem before you can step into the house. Another advantage of real-time communication is privacy. So since real-time communication is based on these direct connections between two peers, it's very easy to enable end-to-end privacy by just encrypting the data in transit. And you need to compare this to, let's say, if you use cloud-based IoT or cloud-based communication. Just, for example, if you send an email, the email from your client to the email server might be encrypted on IMAP-S or SMTP-S using TLS encryption. But once the email reaches the mail server, it's actually in clear text, and it might be forwarded to another email server also in clear text. The protocol exists where you actually can encrypt the email also, but it's not used very much today. But again, using cloud infrastructure, a lot of times you need to have the data in clear text on the servers. But if you use real-time communication, you can easily encrypt data end to end, which, for example, if you have a surveillance camera or anything else which could contain private data, a surveillance camera normally will be, if it's a consumer camera, will be installed in your house. And again, if you use real-time communication to access the camera, data will never be on devices other than the camera or, let's say, the smartphone, if that's the client that you connect to the camera. So the data never leaves, you can say, the end user's full control. And the last advantage is price and cost, especially if the real-time communication is based on peer-to-peer or natural reversal. And you can do simple calculation on cameras. For example, if you have a 4 megapixel camera, that normally amounts to around 4 to 12 megabits per second of data if you do it in let's say H.265 or some other good encryption. And that amounts to around 1.8 to 5 gigabytes per hour. And in units produced in the number of units produced, cameras produced in 2022 was 755 million. And if you have to relay this amount of data, if you multiply all the data together, that's a lot of the server cost that you have to put in there. So especially if it's high amount of data like video cameras or doorbells or similar, where it's all audio video, then cost is also a big advantage of using real-time communication to transmit. And just to show some examples, I personally have experience with these two cars. So on the left, it's an older BMW, and turning on the heater or the climate air condition in this actually takes up to 30 seconds. And to wait 30 seconds to get acknowledged that the heater actually has been started is just a big pain, I tell you. Whereas as a Tesla Model Y, it's instant. It takes some time to connect to the car, but once connected, everything is instantly transmitted. And now we haven't debugged how this actually happens, but we are quite certain that this is actually using real-time communication technology. And this is another examples where we have found a smart lock from a well-known smart lock vendor. We have anonymized it because it has nothing to do with what type of vendor this is. But this is just to show that this actually matters when people they give stars on how good these apps are. So user experience, in user experience, it matters a lot if the latency is not low. But there's also other challenges, since WebRTC is very much about transmitting audio and video, or that was the design goal for it. Another challenge was actually standardization of what type of audio and video codecs is supported in a browser, and WebRTC has standardized this. Also, which minimal requirements for video and also resolution has also been standardized. So you can say WebRTC is both making this real-time communication technology available natively inside the browser, but also standardization of how do you actually, which video types of streams can you play in the browser, and also audio. So that's basically what WebRTC is, from a very high 10,000 view overview. I've tried to put some schematic in here on getting an overview of which part actually does WebRTC then standardize, and how does it work. And here we have two peers, and again, it's a smartphone and a computer running a browser, but it could just as well, one of the peers could be an IoT device. But just for the schematic here, we'll go with the original design goal of WebRTC. So you have these two peers, and they are behind a firewall, also referred as a network address translator. And the first step in creating a connection using WebRTC is that they connect to a stun server, which will tell the peer, the two peers will find out what kind of firewall am I behind, what is the connection data, and a whole bunch of other stuff that I will not go into detail on here. But basically, they create what is called an offer. How can another peer connect to me? And once these peers has analyzed and found out and created these offers are somehow communicated to the other party of the connection. And normally this is done via a signaling server. And this is where WebRTC actually is not standardizing as much. Basically, in theory, you could actually transmit these offers in any way you want. You could send it via an email, you could actually phone call and let the other peer type it in a user interface. But normally what you see is some kind of signaling server is being used to exchange these offers. Once these offers has been exchanged, the two peers will use these offers to create this direct connection. And onto this connection, they will then start sending audio, video, and generic, you can say, data, which then is presented in the browser with the capabilities that I just talked about before, where you know that if you have a WebRTC compliant browser, that they actually support these different video feeds. Sometimes a direct connection cannot be done, and then something called a turn server is used, which is basically a relay server. So you create the video feed will go through this turn server, and normally you'll find the closest turn server to your internet address, you can say, so that you don't introduce as much latency And but again, from our data in our platform, what we see is you get a direct connection 90 to 95% of the time, especially if it's a consumer firewall, so a firewall that is in your home router. If it's more advanced firewalls, like could say a firewall in a hospital or a company, larger company firewall, I would say, then the direct connections are much harder to do, and that's basically on the firewalls just being much more strict. But normally, I would say what we see out in the real world is 90 to 95% connection rate, direct connection rate. WebRTC and IoT. So WebRTC, as I said, was designed for browser-to-browser communication. But again, WebRTC can also be used in IoT, and we see that more and more. And again, of course, right now what we see is mainly in application concerning video and audio. So video surveillance cameras, it could be doorbells where you need the two-way video, because a doorbell with video and audio is basically, you can say, kind of a conference call. So you again have this maybe only video one way, but you will have two-way audio, so that you can tell the UPS guy to place your packet, wherever, or that you're not at home and they have to bring it later on. But we also see application where video feed is secondary functionality, and this could be, let's say, an oven. We have seen ovens that start to have video cameras inside. So here the video feed is not the primary functionality, because, for example, in an oven, the primary functionality is heating your food. But we're starting to see a lot of applications where video feed is secondary. And this, of course, is a lot to do with smartphones has really pressured the price level of cameras. One of the later demos that we have done is using our technology on something called ESP32 cams, which we can see out there on some of the Chinese site, that you can actually buy these modules with a camera and everything. So Wi-Fi, a small 2-core CPU, including a camera, you can actually get that for sub $1. So we see a lot of applications out there now where video feed is actually just the secondary functionality. But what we also see regarding WebRTC is that it is being adopted in General IoT, and this is because you have the video channel, you have the audio channel, but you actually also have something called a data channel, and a data channel is kind of for your own use. You can send any type of data on the data channel that you want, and it could be getting the status, or they could be open the log, or whatever. And we see probably because, again, as I say, we see application where video feed is secondary functionality, but that means if you already have implemented real-time communication to the video feed, why not use the data channel to do some of the other stuff? And that's what we see, that it's moving slowly to but so this is just a more visual of the last slide. So again, video surveillance cameras where you transmit the video feed, but you also have to do the pan and tilt and zoom, and you use the data channel for that, or could use the data channel for that. Doorbells where you use the two-way audio, and sometimes you have doorbells that is actually also connected to a lock, so that you can open the lock. And again, you use the data channel for that. Other IoT application where video is secondary we see a lot of 3D printers with cameras, and again, that's because if you do a 3D print, you want to surveil this print, because if it breaks up in the middle, these 3D prints, they can take hours, and if for some reason the 3D print goes wrong in the middle of the print, it's good to know, and because then you can stop it and reprint. Pet feeders, monitor your cat and dog. Again, video is just the secondary. The primary application is, of course, feeding your dog or your cat. Ovens, I've already talked about that. And again, what we see is some vendors, they'll notice the capabilities of remote videos, and then when you already have established the video feed, why not use the data channel? That is what we predict, and that is what we see out there. And that's basically the last slide of this slide. So I'll over to you, Tarek, on question and answers.
Yes, thank you. Thanks, Karsten. That's great. So would you say the future of IoT is the WebRTC? Or just one?
That's a very good question, because I actually have this slide, and I know you haven't seen this slide, so it's I'm very happy that you actually asked me this question. No, I believe we are going to see both. Real-time communication is not going to replace cloud IoT. We're gonna have both cloud IoT and real-time communication IoT. And that's because they're kind of solving two different problems. So cloud IoT is more for storing fine-grained time series data and doing analysis hereof, and not only on the device itself, but it could also be on the population of devices. So let's say you have 10,000 of devices out there, and you want to know if some of the devices' behavior is especially is wrong, you can say, or is diverging. Then you need to collect all the data in one spot and analyze it. Whereas the real-time communication gives you this low latency, so it gives you the opportunity to create a very high quality user interface. And if you look into the user interface research people, they'll say, well, speed is everything. I don't have this in. We had that on one of our former webinars, where these user experience guys, they said, well, it's the first design criterion that you need to meet is a snappy user interface, you can say, because otherwise you can make it great and look nice and everything, but if it's slow, people are gonna
that's a challenge.
To answer your question very short, no, I don't think all the IoT will be real-time communication. It's going to be hybrid solution in the future. It's going to be both cloud IoT and real-time communication.
Great. So there's great options there for everybody. This is a question to the group. If you guys have any questions for Karsten, please feel free to ask, or if it's easier, if you'd like to type it into the chat box here. Karsten and I can read it, or Karsten can read it. I can read it to him. We definitely thank you guys for joining. We would love to hear any questions that you all have coming from your experiences. If you see IoT heading in a certain direction, any challenges you see, that sort of thing. So our first question, Karsten, is from Asutosh. What is the limitation in WebRTC?
Limitations. I'm not sure. Limitations in WebRTC. depends on what kind of angle you look at. I might need more to kind of have it getting it more specific. Some of the limitations we see today, I can say, is that it's I would rather say so WebRTC was the design goal of WebRTC was browser to browser communication. And okay, and I see, yeah, but let me start. So WebRTC was made and done. The design goal was to establish browser to browser communication. So two browsers could talk to each other, and you could have a video conference call inside the browser. And some of the design choices that was made was done on you can say on the they of course analyzed so browsers today, they run on very large devices. So if you look at your PC, it's gigabyte of memory. Even your phone has gigabyte of memory, and they are well equipped CPU wise, so they have lots of CPU time. So using WebRTC and IoT can sometimes be hard because IoT devices, some of them at least, are not a gigabyte of memory. It's more, if you are lucky, you have megabytes, and if you're on a small device, it's maybe kilobytes of memory. And today, in our platform, for example, you need at least a megabyte of memory, not gigabyte, but megabyte. So in a CCTV camera application, some of these some of the surveillance cameras, have also limited memory. And if you have limited memory, then it's going to be a limitation with WebRTC, because you do have to have some of these you can say built-in you have to use some of these APIs that comes with WebRTC, and they require megabytes of memory. So that's one limitation. You cannot go, at least today, we cannot go down to, you can say, kilobyte of memory. So that is a limitation. And of course, there's also some of CPU, but the most limiting factor is today is memory. So doing WebRTC, you need, I would say, at least something like 10 to 20 megabytes of memory.
Oh, okay.
How dependable is WebRTC? There's a question from Jade. How dependable is WebRTC when used on a network prone to fluctuation and disruptions? So actually, again, this is not a deep dive into WebRTC, but WebRTC actually has some you can say some functionality of WebRTC is actually to exactly cope with these fluctuation and disruptions. So if you have a fast network, it will show you high quality video. And then if suddenly your network gets bad, it will actually lower the bandwidth of the video, getting it more grained. And so actually WebRTC also have some built-in features so that it can actually vary the bandwidth that it's using. If it's very small data that you transmit, for example, on a data channel, this doesn't matter. But it's mostly on the, you can say, high-end video, because that's normally what really can deliver some video, some data from an IoT device. But WebRTC actually has built-in functionality that can actually cope with adjusting the bandwidth to the existing what is actually possible on the connection that you have.
Hi, Carsten. So
hey.
Actually I asked this question because right now we are building on application. Okay, so in that one, right now we are doing the TCP tunnel, and based on that we are creating the port. Okay, but sometimes when normal network hiccup is there. Okay, so due to that our streaming get affected. So every time I have to create a new port for the new streaming. Okay, So how, that's why I asked that how WebRTC is reliable to initialization and means every other process. That's why I asked.
Yeah, but you were saying RTC using TCP tunneling, or?
Yeah, exactly. TCP tunnel.
Okay. Yeah, but that's not WebRTC. That is again,
Yeah,
and that's because that's one of the problems actually with using RTSP, because RTSP doesn't have this feedback where you can actually monitor the performance of the bandwidth and then adjust the bandwidth unless you do it yourself. But it is possible actually to look at the because there's actually data in the when you use TCP tunneling, you can actually ask the two peers on what is the potential bandwidth right now. But then you have to adjust the RTSP video feed on that camera, which is not a built-in feature of like it is in WebRTC, because in WebRTC there's actually a feedback between the transmission layer and video. What is the off? Yes, sorry. Go on.
Yeah, understood, Carson. So I was just comparing the WebRTC and the RTSP. So how initialization process and how it is very fast. Suppose normal hiccup is there, then how it is fast means apart from the RTSP. So that's it from my side.
Okay. What auth supports authentications is available in WebRTC. The transmission itself is actually authenticated on the offer, but otherwise you have to do some of the authentication yourself on the on the channel. It does. Let me see. Did I stop sharing here? Sorry. Now it goes wrong.
Yeah, it's back.
Yeah, back here. If you go to this schematic, you need to do some of the authentication. Is not a it's not a built-in feature of WebRTC. You have to do some of it on the side channel, on the signaling via the signaling server, and be between the two peers. And then once this has been done, you can transmit this authentication down to to be used in the final connection establishment between the peers. But again, right now we are I am technical, but we are getting down to the deep dive, which we have some other persons that should. But if you're interested, we could definitely create a connection between some of our real technical guys that knows all these things, because again, WebRTC is it's a very big topic. So here we have tried to make it more manageable. And again, if we need to go down on how does the authentication, how can you do authentication in WebRTC, then it gets really complicated. And I will also say that one thing about WebRTC is that it is not trying to define it all and say this is how it has to be. Again, for example, the signaling server, it's very some standards have been designed now to how do you do a signaling server, but in the original WebRTC, there was nothing on how do you get the offers from one peer to the other peer. That was not defined in a standard. That was just something you had to make yourself, and that was to make it an open standard, so that you could use it. You could transmit the offer via a WebSocket on a signaling server, or you could create your own side channel in any way you want. And that is also what we use in our platform. We are using our platform to actually do this signaling. And as I say, it's not well defined, and it's not well defined for a reason, and that is WebRTC wants it to be open so that you could use WebRTC in many different setups, probably including IoT. I'm not sure that was the idea from the start, but it definitely opens up for example, using WebRTC in IoT. Yes.
Sorry, I was talking, it was muted. I think there's always opportunity to get more of a deep dive, I think, with our technical team, obviously. And we can definitely do that with you guys.
Yeah, the memory, again, there's, when I say a number, it depends on a lot of things. So there's a question on repeating the memory hardware requirement. So normally we say 20 megabytes, but it depends on how many open channels do you want at the time, and many other things. But 20 megabytes is normally the memory requirement that we say, and that has to be to do with also how many external libraries. So WebRTC libraries that has to be loaded. It's not so much, and again, it's also in our platform, 20 megabytes, and we have tried to really narrow it down. And also, we are working on actually getting it. Our hopes is that we can get it down so you can run it on a real-time operating system like FreeRTOS or Zephyr or some of the other really tight small operating systems that are using maybe kilobytes. But right now we are in the megabyte, so let's say 10 megabytes to 20 megabytes of memory, and normally running Linux or similar. No problem.
Thank you, Philip. So just curious, Karsten, while others are thinking if there's more questions. I mean, usually when a company comes to us wanting to speed up, let's just say latency, is that usually coming directly from their customers? Is that why they reach out to us? Or, I mean, who notices these things first? Is it the internal team, or is it the customers that see this on the outside?
It's normally customers, I would say, because and that can sometimes be a problem, because then you have already launched your first product. But yeah, it depends. Again, I think because and this is very normal because of the history, you can say, of IoT.
Mm-hmm.
Because when we started out with IoT, let's say the first IoT was very, I mean, 30 years ago, but it gained traction, let's say 10 years ago or something like that. And when you did the first IoT products out there, the just being connected to a device, I mean, that was new. So people were not that skeptical, you can say, on having 5-second latency, 10-second latency, 30-second, maybe even minutes of latency, because the alternative was being not connected. But as we move on, people are just getting more and more used to having
Faster.
Yeah, faster and faster, and that's how the tech world works. I mean,
Yeah.
expectations and especially with the introduction, I would say, because in the start of IoT, the first IoT products I helped doing, the iPhone was not invented yet, actually. So it was PC and browser based, and at that point, also some of the websites were actually pretty slow. But today, when you install an IoT app on your smartphone, I mean, the IoT app is just next to all your other apps, which are very fast and very snappy. So when you start up your IoT app, let's say it's your smart plug app or your video surveillance camera app, then you expect it to be just as snappy as all the other apps that you have on a phone. So it's very, I mean, I think that some of this actually, so this requirement to actually have this very low latency connection actually came together with smartphones and all the apps that you have today, because people cannot see the difference between an IoT app and a normal email app or whatever apps that you are using on your phone. If you had released a product, let's say 10 years ago or 5 years ago, then suddenly people just and you want to transition to an app, and then suddenly latency is top of your mind. But what we see normally is that it's kind of the next version of the product. It's very hard normally to go back and implement something new inside an old product. So it's more when they then start design of new products. That's when people they connect to us.
Yeah, I could. Customer service is a big driver for this. Obviously, that's a big part of the business, and that creates competition with customers and that sort of thing. So it really behooves everybody to kind of get in, to the new way of doing things to meet the customer's expectations, basically.
Exactly. And again, also since a lot today is actually designed. I mean, a lot of the IoT systems today is designed on this cloud. Let's see here, the bottom down here, the cloud-based IoT. Introducing real-time communication to IoT is a new thing, but that's also what we see, because once you collect data from your devices and people get access to these data, then the next part will be, how do I connect to the data? How do I connect to the device that maybe is doing something wrong? So it kind of depends also if it's a consumer-based device or it's an industrial-based device, because if you collect a lot of data on industrial devices, then you find out, okay, some of them are doing something that is weird. Well, I need to debug, I need to reach out to the device. And then, how do you do that in a way where you can, remote debug? Well, real-time communication is since real-time communication is just as you were sitting just beside the device. That's what we see people they call us for, because again, real-time communication is basically just a long cable, you can say, through the internet. So all the debugging that you get on a cable, this shouldn't be about how you debug a device, but normally what you do is you attach a debugger via a cable or something like that, and then you look at the data that is coming out, but this cable can actually just instead be a virtual cable using a real-time communication means.
Oh, very nice. Yeah, definitely see the need and the value for sure.
Yeah. And that's also what we see sometimes. So people they have done an interface on the device, let's say a UART or some kind of serial connection on the device, which would normally be used for debugging and accessing it from a PC. Our technology is great. Our real-time communication technology is great for actually doing the same thing. Instead of having to connect to it from a PC with a cable, you can just do it virtual. So you can create kind of a virtual cable that accesses the same PC program that you already have done. So, but of course, this has nothing to do with WebRTC, so in the browser, but that's also what we see. So there's again, it's two different types of IoT, and especially I think real-time communication is lagging the cloud-based IoT. But that's because that's what you want first. You first want to collect data, then you want to connect to the device.
I see. That's great. Does anybody else have any questions for Karsten today? That definitely was a lot of great information. What I will also do is to everyone here, I can send the recorded version so that you guys have access to it. If you have any questions afterwards, you can play it back and see some of the information that was discussed here. And obviously, if you have any questions from there and want to talk to our team, please feel free to respond to my email, and we'll take care of you as soon as possible. Our goal is to provide the best, in terms of knowledge and customer service and support for everyone. So please let us know how we can help you guys. And we thank you very much for joining us today. Thank you, Karsten, for sharing all this with us. And
thank you for the opportunity.
Definitely.
Everybody.
Well, thank you, guys. Thank you. So
Thank you.
I'll send the video after this, and we appreciate your time.